solution. Welcome to Codership's webinar. This is our first webinar for the year. And my name is Sakari Keskitalo. I'm COO at Codership. 2017 is 10th anniversary for Galera Cluster development. 2007, our three co-founders had already developed 3 MySQL replication and clustering solutions. They knew what are the drawbacks of the MySQL master-slave replication, and they used academic research to build up a new high availability clustering solution for MySQL. There is a sound theory behind Galera Cluster. Our product is Galera Cluster for MySQL, as you already know. It's an open source product, and our business model is to sell support to help you with the troubleshooting, to fix bugs if you happen to hit one. Since then, in 2016, we have had over 1 million downloads. Galera Cluster is included in Linux and OpenStack distros, and there are thousands of users with different kind of applications for Galera Cluster. Typically, the Galera Cluster users choose Galera when they cannot tolerate downtime, they cannot tolerate data loss, and they want to have a replication between data centers and in the cloud. Galera is also chosen because it's very easy to use and you can scale with Galera Cluster. There are 3 different Galera Cluster variants in the marketplace. There is Galera Cluster for MySQL from Codership. Then there is a MariaDB Enterprise Cluster and Percona ExtraDB Cluster. All of these are based on Galera replication, plugin, and tool. We work very close together with MariaDB when it comes to bug fixing, testing, and roadmaps. MariaDB is our preferred partner, our certified partner. And with that, I will give the microphone to Philip Stoev, who will do the actual presentation of today's webinar. Philip, go ahead.
Hello everyone, my name is Philip Stoev. The topic of today's webinar is DDL statements. This webinar is part of a series of Galera Cluster best practices that we started recently. In previous installments, we discussed other issues that are of interest, such as taking backups or monitoring your cluster, and slides and recordings for those previous webinars are available on our website. So for this webinar, here is the agenda. First, I'm going to do a very quick overview of Galera Cluster, and then we're going to discuss how Galera handles DDLs and how you should prepare for when you want to change your database schema or you want to run some DDL statement. And we'll also see step by step how to do these DDLs under different strategies provided by Galera. And finally, we will discuss some recent developments and future improvements that we have. And we'll end with the Q&A session where you'll be able to ask questions using the questions box on your webinar interface. So first, a very quick overview of Galera. It is a synchronous multi-master application solution for MySQL, meaning that each transaction is immediately replicated on all the nodes at commit time. Galera does not tolerate stale slaves. It is multi-master. You can read and write from any node, and Galera will take care of any transaction conflicts for you. They will be detected and properly reported. It is based on replication in the sense that a copy of the entire data set is available on all the nodes, and Galera takes care of joining new nodes automatically. Currently, the data set is not sharded between the nodes. All the nodes have a complete set of the database and can answer any query about it. And it is based on MySQL. The data is stored in the well-known InnoDB storage engine, and we provide binaries for 5.5, 5.6, and recently we have started providing binaries for 5.7 as well. Furthermore, the product has some very nice features. It is able to detect and recover from a node failure within seconds. It has very strong data consistency protections, and it prevents you from shooting yourself in the foot when it comes to making changes to your data. And it has extensive support for clouds and wide area networks, meaning that you can have clusters with nodes that are in different cloud providers, different regions, different availability zones for further disaster recovery and general operation in wide area networks. So first, a few general words about DDL statements in Galera. Galera strives to make your database experience as close to MySQL as possible. That is why when using the InnoDB storage engine, when you run a select query, for example, in Galera, the query will be processed in the exact same way that it will be on a standalone MySQL server. With DDL statements, certain restrictions apply, and we will discuss them further down in the presentation. And most important thing to note is that Galera does things with data consistency and data protection first in mind. Because you have the same data on multiple nodes, special care needs to be taken to keep this data consistent. Because of that, when the MySQL documentation speaks about non-blocking DDL or online DDL, those terms do not translate directly to Galera, because even if a statement is non-blocking when you run it in a single node MySQL server, it may block other queries when you run it in Galera, and we'll discuss that. So with Galera, it is fairly important to think about and plan your DDL execution in advance. Galera provides two ways to run DDL statements, and we will cover both of those in this presentation. The default one is what we call total order isolation, or TOI. What happens is that as soon as you issue the DDL statement, Galera will take care of running that same statement on all the machines in the cluster. But in order to do that safely, Galera needs to stop all other transactions from committing while the DDL is running. Even if those transactions operate on other tables in the cluster or on other database schemas, they will still be blocked, which is a very important consideration to take into account when planning. The other method is rolling schema upgrade, which is a way that Galera allows you to run the DDL statement manually, one node at a time, in order to avoid this blocking of the entire cluster. But this method also has certain considerations to go with it, and we'll discuss them as well. Before we go into individual methods, let's discuss your application and DDLs that may happen from it. It is important when running an application with Galera Cluster to know if the application wants to execute any DDLs on its own, or if the object relational mapping framework has a tendency to run such statements automatically. We have observed in our real-life customers that some applications run a lot of DDL statements that you may not expect them to run. A frequent occurrence is for an application to repeatedly run create table statement at connection time. So when your clients connect the application, even if it's not necessary, will issue a bunch of those create table statements, even if they are most likely to fail because the table already exists. And if you have hundreds of clients connecting, imagine hundreds of statements being run at the same time, and Galera needs to replicate and run all of those, and this is unnecessary work. So it is important to figure out if your application has any facility that would do that, and try to avoid it. Another scenario that we have observed is when the application starts, it detects that the database schema needs to be upgraded because the software, the application itself was upgraded, and the application immediately proceeds to run the required outer table statements, even though this is not expected. Sometimes it even happens without much notification to the user itself. The application internally decides that it wants to run those outer tables, and it starts running them. With Galera, this is not optimal. So check your application. If temporary tables are used, that is totally okay because Galera does not replicate temporary tables. But any other sort of DDL statement should ideally be run by the administrator in some sort of a controlled environment. So you don't want this to happen unannounced. And this goes with the second bullet point here, is that you should take control of those DDLs. It does not mean that you should run them manually. You can still script them, but it's important for this action to be controlled by the DBA. One way to do this is to revoke those database privileges that allow end users to run DDL statements. In certain environments, this may be an overkill, but in others, it is a straightforward thing to do. If you do not expect your application to run DDLs at all, do not give your application those privileges. And this way you will not be surprised further down the road if the application is changed in any way and begins to run those statements. A lesser solution would be to log all statements and check for DDLs. You can use the query log, I guess, or you can use some more specialized audit plugin to make a list of all the DDLs that are being run and who runs them, which will in turn prepare you for taking care of this, for taking control over those DDLs. Because what may happen is that when your application starts small, with small tables, if running outer table is very fast and you will not notice it. But imagine that if your application grows into the terabyte-sized data, then you do not want any unannounced DDLs to happen. So it is better to plan early while your data set is small in order to avoid any disappointments later when your data becomes too large to manage. It is also possible to use your load balancer to filter out DDL statements. There are some proxy products on the market that are able to detect and filter out DDL queries if that is more convenient to you. Also, the course of action to take depends on the actual DDL statement that is under consideration. So, the usual create and drop tables, stuff that does not have to read a lot of data, process it, and write it back to disk is usually fast enough. So there is frequently no need for special planning. But still, it would be nice to control even even such statements, unless they operate on temporary tables. Because while the statement is executing, your cluster is blocked. So imagine that the create table statement that usually runs fine suffers some sort of a I/O bottleneck. For example, you attempt to place the table on some partition that is not, on some disk partition that is having issues or that is not available. Such one-off events can cause this statement, which usually runs very fast, to to block, and this is going to cause issues for your entire cluster. With outer table or create index, you should assume that those statements will take some time to run. So those are the statements that require most planning. The speed with which those statements will run depends on your MySQL or MariaDB version, because certain versions have optimizations for certain statements, and depending on your version, a particular statement may be very fast to execute. For example, a statement will not rebuild the entire table, but it will only change a few bytes in the header of the table in the metadata. For DDLs that support in-place operation, this does not mean with Galera that this statement is fully non-blocking. What it means is that MySQL will avoid creating an entirely new copy of your data from scratch in a new table. But it does not mean that whatever transformation is happening internally will be instantaneous. There is still work that MySQL needs to do, even for those statements that can be run in place. So do not be fooled by this online DDL support. It still requires planning and considerations. And finally, some statements just require creating a complete copy of the entire table, which usually takes a lot of time. And those are the statements that you absolutely must plan before executing. There is a separate set of statements, optimize table, analyze, and all those. They support something, a modifier to the statement called no write to binlog. If you use it, then this statement will not be replicated by Galera. It will be run locally, and if there are no concurrent accesses to that same table, it will succeed. So those statements are a separate category, so to speak. In the presentation, we mostly focus on long-running outer statements. Okay, so the first method that we'll discuss, the default one, called total order isolation, means simply running the DDL statement on all the nodes right away. This is what Galera will do. If you use this method, here are the general principles that will apply. So first, no other write transaction can commit anywhere on the cluster, even if it's on some other table, even if it's on some other schema, all the write transactions will still be blocked while this DDL is in progress. As mentioned before, even if the MySQL documentation lists that a given statement is online, or it says that you're still allowed to update the table while the statement is running, this will not apply to Galera. Galera will lock the table and will lock the entire cluster for the duration of the DDL. If you had any transactions in progress when you started the DDL statement, they may get a deadlock error. So this is something else to think about. And finally, if you have used this recept sync wait or variable to enforce that your queries always return the freshest possible data, such queries may time out if a DDL statement is in progress. Because by definition, while the DDL is running, the data is not 100% fresh anymore. So those queries may time out, and they will return an error, lock wait timeout error back to the client. Some more considerations to know. Very importantly, DDL statements cannot be queued once started. This is partially because in MySQL, running a DDL statement is not a fully transactional procedure that you can roll back at will. So Galera will prevent you from using queue statement or queue connection to queue a DDL statement that is already in progress. So once you have decided to issue the statement, your best bet will be to wait for it to finish. And if a node dies while running a DDL statement, when you restart it, it may need to rejoin the cluster using SST, meaning that it may need to fetch a complete snapshot of the database from another node. So it is best to prepare so that you don't have to queue your DDLs. And it is best to start with a cluster that is healthy, that is functioning properly, and that you do not perform any adding nodes or removing nodes while the DDL is in progress. And finally, very important consideration with Galera, if there is an error with the DDL statement, it will be ignored. So the Galera will replicate your DDL statement on all the nodes and will run it on all nodes, but then it is your responsibility to check the server error log for any errors that may have happened, because they may not be obvious using the MySQL console, for example. And you also see a .log file created in the MySQL data directory for each such failure. And if you have an application that repeatedly attempts to run statements that repeatedly fail, you may observe a situation where you accumulate a lot of such log files in your data directory. Okay, so now that we have established the general principles around total order isolation, here is how Galera actually does things. So as soon as you issue the statement in the console or using your application, the statement will be immediately sent to all the other nodes for execution. And each node will make it so that in the logical sequence of events, in this stream of transactions that goes through the cluster, this DDL will run at exactly the same place on all the nodes. So the node will wait until the time is right to execute the DDL, and then it will run it in a manner that allows all the nodes to run the statement in a consistent fashion, in the same place in the binary log, and in a way that is safe for your data. Which means that after you have run your DDL, the binary logs, if you use them on each of the nodes, will be identical, because Galera has taken care of running the DDL at exactly the right time on each node. And what will happen on your console is that you will run the DDL, it may return locally from your console, but it may still continue to run on your other nodes. So it is a good idea to check the process list on the other nodes, to check the error log on all the nodes to make sure that the statement has completed everywhere as expected. Here is the recommended procedure that we advise for running such a statement. So first and foremost, it is ideal if you are able to practice running this DDL statement on a test cluster, if you have it, against the data that is as close to your production data as possible. This is important for various reasons. One is so that you know how long the statement takes to run, and to make sure that there are no unexpected surprises down the road. For example, running out of disk space, or seeing that your I/O capacity is not as you expected it to be, and the statement takes longer than you thought it would be, things like that. Or a statement that you expected would not rebuild the entire table, actually rebuilds the entire table. So once you have these initial observations about your DDL, it is a good idea to schedule a dedicated maintenance window for the DDL statement. Even though Galera will block all the concurrent queries, so having concurrent queries will not cause your data to become inconsistent or anything of that nature. Those all queries or those all transactions, if they have any write component in them, if they're performing updates to the database, will block. So ideally, you would want to handle this on your application side. Make sure that you have a defined maintenance window. Make sure that the application is okay with the DDL statement running, and only that then you can proceed. So then you run the DDL on a single node only, and it will automatically be replicated to the rest of the nodes. And as mentioned before, once you're done, make sure that the show process list looks okay. Make sure that the flow of queries through the cluster has been properly restored. Make sure that the show creates table statements on all the nodes for the table that you have just modified, returns the expected output, and that this output is identical on the nodes. And you can also check for any errors in the error logs. So as we mentioned before, there are some potential failure situations that you may encounter. For example, if you're running the DDL statement locally in the console and you get an error, this still means that the statement was replicated and run on all the other nodes in the cluster. They may get the same error, or they may get a different error, or the statement may happen to succeed for some reason on those nodes, especially if they have become inconsistent due to some situation in the past. So if you ran a statement and it failed locally, before you proceed, just check the other nodes, check their logs to make sure that it failed there as well, and that nothing diverged. And only after you have confirmed that, you can retry the statement with some modifications and have it succeed. On the other hand, you can face the opposite situation. In your local console, the statement may succeed, but when executed on some other nodes, it may fail. And this will not become apparent in your local console. You will have to check for this situation yourself. As mentioned before, very frequently it is a disk space issue that has occurred on some other node, or your data has diverged for some reason in the past, has become inconsistent in the past, and now when you, for example, try to add a unique key to your data, to your table, such an inconsistency gets exposed, even if it happened a long time ago. So if you're doing any such operation, check the outcome, check the logs, and they will tell you if the statement succeeded on all the nodes or not. And also, very frequently, the statement takes longer than you expect it to be. This is especially true on very large tables, on very large databases. So previous planning, testing, and estimations are important to know how long the statement is expected to take, so that you're not surprised by the length of the outage that happens because of the DDL statement. The next way of running statements, DDL statements in Galera, we call rolling schema upgrades. As mentioned before, what happens here is that the statement is run manually by you on each node in the cluster separately. So Galera provides some instrumentation around that, some help to get the procedure going. But essentially, what happens is that the administrator will need to visit each node in a sequence and run the statement on each node separately. What Galera does is when you indicate your desire to run a DDL statement like that, the node will temporarily fall behind the cluster while the DDL is running, but the rest of the cluster will continue to commit transactions, will continue to run as usual. So what will happen on the local node is standard MySQL locking rules will apply, and nothing will be locked on the remote nodes. But the local node will stop receiving and will stop applying replicated transactions from the other nodes. That is why in practice what happens is that it appears to fall behind the rest. It continues to receive those replication events, but it does not apply them locally while the DDL statement is running, so that the DDL statement can safely run to completion without being in conflict with another transaction or without being aborted. And in practice, this means that the rest of the cluster can continue to run, and once the DDL on this node is done, it will catch up with the rest of the cluster, and you can move on and run the same procedure on the other nodes as well. And one practical consideration of doing this on a node-per-node basis is that the binary lock on each node will contain this DDL in a different place in the binary lock, in a different under a different GTID, so to speak. So if you happen to use this binary lock for some other purpose, such as backup or restore, or you're using this binary lock as a source for a synchronous-based replication, this is an important consideration to have. That by running the DDL separately on each node, you have caused the binary locks to become different. The end result may still be the same, but the order of the events internally in the binary lock will be different. There are some considerations regarding the application, even if you choose to use this rolling schema upgrade method. It does not come for free. Even though it causes less downtime, it is important to know that while you're doing this rolling schema upgrade, the cluster will contain some nodes that have the old schema and other nodes that already have the new one. And it is important for the application to be able to handle this situation successfully. So if you have your application connected to a new node or to an old node, it should not misbehave because of that. And as we mentioned before, the node that is currently running the DDL has fallen behind the cluster. So ideally, you should be able to remove it from the load balancer so that it does not begin to serve stale data to your users. And finally, setting your schema upgrade method to RSU is a global setting for the node. So your application should not attempt to run any other DDL statements while you're executing this entire rolling schema upgrade sequence, because those statements will also be run only on the machine and not replicated elsewhere. Some more discussion about the practical considerations around having two separate schemas in the cluster at the same time. It is important for the queries in the application to be written in a certain way to take care of that. For example, you should not attempt to insert into a table, into a column that does not exist on all the nodes. If you add a column to your table on one node and you immediately force your application to start using this column, then all those transactions will be writing data that the other nodes are unable to understand because they still do not know about this new column. So most likely your replication in the cluster will fail and the cluster will split apart. So it is important to write your applications defensively until the actual procedure is complete. Once all the nodes are on the new schema, once all the nodes know about this new column that you just added, it is of course perfectly safe to start using this column in your application. The same applies for even for select statements. If you use select star in your application, you may see that the nodes that have the old schema and the nodes that have the new schema have started returning data sets that have a different order in their columns, or maybe they were produced by a different optimizer query plan. And finally, if you just do inserts into your tables without mentioning columns specifically, this statement may cause different results to happen depending on which node you're running it. So the best approach would be to code your application defensively, make sure that it is able to run on both the old schema and the new schema, and make sure that the application does not begin to write data in the new schema while there are still nodes in the cluster that have the old schema. So once we have the application accounted for, here are again some preparation steps for rolling schema upgrades. Practice the DDL on a test machine. Again, you should know how long it takes to run, if it produces the result that you're expecting, and so forth. Practice taking nodes out of the load balancer, as you will need to do this repeatedly for each node. And finally, make sure that you do one DDL at a time in order to avoid any confusion as to which node has which version of the schema. So make sure that you run one DDL one at a time on all the nodes, and only after you have finished with this DDL statement and you have confirmed that everything is good, then go back to the first node and run any subsequent DDL statements that you need. And the step-by-step procedure for rolling schema upgrades is as follows. So first, on each node, as discussed before, we remove the node from the load balancer. This is not strictly necessary, but keep in mind that this node will fall behind the cluster. So if you have a DDL statement that runs for 6 hours, for example, this node will continue to process select statements, but it may return data that is now up to 6 hours old. So it is generally a better idea to remove this node from the load balancer and leave the rest of the cluster to handle your incoming traffic. Then you run the DDL statement itself. You wrap it around this syntax. So with the first one, we set the online schema upgrade method to RSU. Then we run the statement, and then it's important to not forget and to reset the variable back to its default value in case you have further activity going on in the cluster. Then it's important to let the DDL statement run, and after it is complete, you will observe that the node is now starting to catch up back with the cluster. So you will see the values in this reset local redsef query variable go down until they approach 0 or whatever is the value at rest for your particular cluster. So once this procedure has completed, once this variable has returned to its normal levels, this means that the node has caught up with any updates that happened in the rest of the cluster in the meantime. And once you have achieved that, you can restore the nodes added back to your load balancer and make sure that there are no errors at the application level from using this node with the new schema. And once you have that, now it's time to do the same procedure on the other nodes. Of course, if you have a large cluster, this is going to be troublesome to run manually every now and then, and there will be some potential for operator error if running those steps manually each time. You're welcome to automate them, but still make sure that your automation contains all those error checks that were previously mentioned and is able to account for all those situations that we have discussed previously. And finally, some words for some improvements in the area that are currently available or will be available in the future. In the recently released Galera Cluster 5.7, certain DDL statements have been made much faster or instantaneous. We just published a blog post about this. I made some very quick benchmarks, and for those statements that are listed here, there is a noticeable performance improvement. For outer table add key, for example, this statement now runs without rebuilding the entire table. Outer table change column can now run for certain types without touching the data at all, so it only modifies the table metadata. And finally, optimized table has been made faster as well. So this is a welcome improvement, especially if you use total order isolation. The total maintenance window for your cluster will now be much less if you use statements like that. And in the upcoming Galera Replication Library version 4, we'll be introducing a new schema upgrade method that will allow certain outer tables to run without blocking the entire cluster. You will run the statement only once, but still while it is running to completion, other schemas, other tables will continue to be usable, and there will be no downtime for those. And finally, we'll be introducing a new consistency check that will check if a particular DDL statement succeeded or failed equally on all the nodes. So for example, if you attempt to create a table that already exists, this consistency mechanism will check that all the nodes agree on this and all the nodes return the same error code. Table does not exist. But on the other hand, if you run a DDL statement that you expect to succeed, this consistency mechanism will make sure that the statement succeeded on all the nodes. And if there was some previous inconsistency, like the one we discussed, where, for example, previously your data for some reason acquired a duplicate value in a column that you thought was unique, if this inconsistency is limited to only some nodes in the cluster, those nodes will be, this situation will be detected, and those problematic nodes will be taken out of the cluster until you're able to fix them manually. So if you have a 9-node cluster, for example, and you run an outer table statement that succeeds on 8 nodes and fails on just 1, this one node will be taken out of the cluster until you have had the chance to fix it. And the cluster will continue running with the nodes that are in agreement as to what the state of the database must be. Okay, I hope you found this useful. Now we can take some questions. Please, the question box on your GoToWebinar interface, there may be an orange arrow on your screen that you can click to display this this question panel. So let's try to answer some questions now. Just a second. Okay, first, there is a question whether in the presentation I said DDL execution errors are ignored. Does this mean that NoSQL error will be returned to the application? No, what it means is that the SQL error that happened on the local node will be the error returned to the application. And if any errors happened on the other nodes, those errors will be logged in the error log for you to see, but the cluster will keep running. It will take no action because of those errors in the current version. It will not stop replicating or anything like that. It will just continue on. That is why it's important to check the error logs for such errors. Next question is, what would this new method NBO that I just mentioned stand for? It stands for non-blocking ordering or something like that. The idea is that in Galera 4, in the upcoming version, when you begin to run a DDL statement, Galera will lock this particular table on all the nodes and then run the DDL. But this will allow other queries on other tables to proceed separately. But you will observe that the table that you're currently operating on is locked on all the nodes. So it's an improvement of just locking the single table under question rather than the entire cluster. A question comes in, will recording of this webinar be available to access in the future? Yes, we tend to post the webinars on YouTube, and you will probably get a link to the recording from GoToWebinar, from an automatic email from GoToWebinar. Okay, will NBO work for all outer statements? We are currently trying to evaluate which statements we should enable in the first release of this functionality. It will run for all outer statements, but it will still lock the entire table that is being altered for both reads and writes. So you will be able to add indexes and drop indexes and add columns and drop columns, that is for sure. So those most frequent statements that take most of the time will be runnable in the future in a non-blocking fashion. Next question. Are DDLs replicated the same way as DML statements across Galera cluster? Yes, they use the same underlying replication architecture. The difference is that Galera takes care of locking the cluster before the DDL is replicated, and also the DDL is replicated even before it is run locally. So even if you get an error when you run the statement locally, it has still been replicated before you got this error, and it will also be run on the other nodes even with the error. Question, does the locking of the entire database through the total order isolation process apply only to the affected database or to the whole cluster? Currently, the entire cluster is locked for all write transactions, regardless of which database they touch. As mentioned, in a future version, we are working to relax that, but right now it is all transactions, all write transactions. Next question, what about partitioning? What is the best way to create and delete partitions on tables? Creating and deleting partitions is supposed to be very fast. What happens behind the scenes is that simply a new file is created or a new file is deleted. So we have seen people that simply run those statements under total order isolation without doing any further considerations. But still, this is something that you need to check, because not all statements are created equal. For example, you can run statements to add or delete partitions very fast, but for example, if you ever want to run a statement that changes the entire partitioning format or some other thing that requires rebuilding the entire table, then now the statement takes forever to run. So this needs to be, of course, planned in advance. Next question. In Galera, can we use InnoDB engine or other engines are also supported? Currently, only the InnoDB storage engine is supported with Galera Cluster. There is an option to replicate MyISAM, but this is strictly for replicating the MySQL system tables that are around user privileges. So we do not recommend any MyISAM replication in production. Okay. Let me check if some other questions have arrived. Any plan to support XA transactions in the future? This is not on topic for this webinar, but yes, we have had questions about this. We are considering whether it is possible or not in some future version. So if you have some specific scenario for HA transactions, please send us an email and describe what you're trying to achieve, and we will see if there is something that can be done in a future version. Back on your screen, you see our website, and we have a discussion group also on Google Groups that you're welcome to subscribe to. Next question: how does Galera replicate versus the files using the file system or using binary logs? What Galera does is ship the binary log events to the other nodes, and the other nodes apply those binary log events individually. Okay, then we are almost out of time. Thank you very much for joining this webinar. We hope to have further webinars in the future. If you have any ideas about topics for webinars, send us an email as well, and we will try to accommodate. We will try to make a recording available to you as well, and we will also post the slides that you just saw. Thank you very much, and have a good day. Goodbye.